in 2016, we started their journey by working on Cisco AI network analytics. And we presented at the Tech Field Day just 1 year ago. We've got many innovations over there. I'll give you a quick recap because we now have many, many customers, many, many results, and we are delighted to see this product. But today, what we'll do, we'll be focusing on something slightly different, which is Cisco AI endpoint analytics. So let me now say a few words again about Cisco AI network analytics. So on that slide, I'm just showing the three pillars, right? So the pillar number one is about real-time anomaly detection. And it's good to remind that because a lot of people talk about baseline and things like that. And that's exactly what we do here. We are using multiple machine learning models. The goal being that we know that you cannot set a specific threshold to monitor a given KPI. It depends on the KPI, it depends on many, many parameters such as the SNR, the number of devices being connected, the type of device being connected, and things like that. So what we do is that completely automatically, the system will learn what are the normal values. And this is the green band that you see at the bottom. We do that for 25 KPIs and more coming. And then the blue line that you see is basically the actual value. And when you exceed from this band, we raise an anomaly. And that's learned automatically, dynamically. Everything is pushed to the cloud, fully encrypted with full privacy. We do root causing. We have a system with 3 layers. One is about the machine learning models. The second one do root cause analysis. The third one allows you to give some feedback to the platform to learn even more. The pillar number 2 is about trend and insights. So in contrast with the first one, where we do real-time anomaly detection, in the second one, we look a bit more of a longer term. So you can see a lot of bubbles over there. And each one is an AP, an access point. We look at many parameters of each access point, and we start to see when we have long-term deviation compared to the behavior of the other access point. So we can detect if you start to have a KPI for a given AP that is slowly deviating from the other APs. So that allows you to give some trend and insight. The last one is called comparative analytics, and this is all about comparing your network with similar network.
JP, do you have any statistics on how many problems or issues that you fixed in the field with your trends and insights and issue detection and analysis?
Yeah, we have many. Thank you for the question. The one thing was really the quality. So what we do, right, is that we measure the success rate. So we look at the number of times we raise an anomaly. We look at whether it was a real anomaly. One of them lately was a DDoS attack on a campus, for example. So because we looked at the throughput, the average throughput for the users was way below the norm. So we could detect that indeed there was a DDoS attack on the site. We had another one where we have a lack of connectivity. I could go on and on. If we had more time, I would show you many more. On average, what I can tell you, we almost never raise more than 10 anomalies every day because we don't want to have a system that is too noisy, but we want to have a very high success rate in terms of validity of anomalies. That's super important.
All right, thanks.
Sure. All right, so let's move on to the next slide. And here is what we're going to talk about today. We're going to talk about security. And in 2 ways, right? One is how can we improve the classification of a device. You guys know very well, there are a lot of rule-based systems that we look at the OUI and many of the parameters, and based on the rules, we do classification. We added the machine learning AI component to it. I'll show you more about the ML piece, but Krishnan will now walk you through that. We also have a spoofing attack detection for this project. And you see the one at the end, the coming, is actually more than coming because for some of them it's about to ship, and I'll tell you a little bit more in a few minutes.
JP, can I ask you a question?
Of course, please.
So you're doing peer comparison. I have 2 questions. One, how are you creating your peer groups? Are they based off of industry or based off of comparable baselines? And then also, are you threat sharing anonymously, of course, through peer groups? So say
Yes.
You know, if there's an attack on an IoT device in one network, are you flagging that in the network of another peer group?
Yeah, so, on the first point, we looked at that, the classification per industry, but the reality is that it doesn't work so well. For example, if I could give you an example about universities. We looked at multiple campuses, and a campus in Manhattan where you see 100 SSID, and you take another one in a more suburbs of a city, you have very different patterns. So we thought that it was not so good to do that. Instead, the approach that we prefer is to cluster based on commonalities between multiple networks. So in other words, you could be using machine learning to look and say these networks are similar, and they may not be in exactly the same industry, but it's very comparable. So this way we can show where you stand in your group. Across peers, we don't do that. We just show you where you are comparing to other customers having a similar network. Does that make sense?
Yeah, and then addressing the threat sharing issue. Are you flagging certain devices or anything?
So in this particular context, what we are doing is mostly it's not too much focused on security. It's really focused on anomaly detections. So we have Talos, obviously, and many other products that instead of looking at the security aspects. But in this particular case, it's really about anomaly detection. To say, when we look at the average throughput for a given class of application on a given site, you should be getting much more. The model, considering the environment, has predicted that you would be between X and Y, and you are way below. So that's the type of information. It's mostly for troubleshooting, capacity planning, long-term trending as well.
Okay, thank you.
So just kind of a follow-up to that. So this isn't necessarily looking beyond my own network to bring in insights from other customers or other scenarios, at least as a way to seed. I wouldn't say that my network is the same as yours, JP, but at the same time, maybe there are things that are being observed in my network that could benefit you.
Okay. So I see what you mean now. So we do have this capability because the models, they basically, you can leverage the fact that you have a common database. So for privacy issue, we are a bit paranoid about the privacy. So, for example, what I can tell you is that when we push the data in the network, we no longer we don't know who is the customer, there's no MAC address, there's no IP address, we don't see any of that. But although this is fully anonymous, in some cases, you may use a model that is common. That's what we call a global model as opposed to a local model. But in some cases, when you use a global model, you benefit from, in terms of training, you benefit from the whole database. So if there's some interesting stuff, interesting mechanism that has learned on a given customer, they could be leveraged on another customer, which is a way to leverage the database. Because you raise a very good point, which is it's all about diversity and volume of the data as well. So that's how we build up good models, by the way, because we can leverage across databases.
What you're trying to say in this slide is that Cisco AI and ML has been used by various products of Cisco with ICE leveraging this capabilities today, and you're going to bring up this capabilities to SD-WAN product suite as well?
Yes. So multiple things, right? So we started off a long time ago, but in terms of DNA platform, what we chose to do was to build the platform in 2016 and start shipping one line of product, and this was wireless. So we really wanted to focus on wireless. Of course, the point is that this platform has been built to support many, many different kind of use cases. The second one was about security and device classification, and we'll be focusing on that one. Of course, in parallel, we've been working on SD-WAN, and that's exactly what I explained at the end of this presentation is what are we seeing for the SD-WAN domain and what will be the next big thing we're working on. We cannot disclose it yet, but I can give you a little bit of a flavor because you're right, it cannot be one use case. It's many use cases across multiple domains, and we're going to stitch all that stuff together. Yeah.
Hey, JP, is this a SaaS application?
Yes, it is. It's completely built in the cloud. Yeah.
It runs in the public cloud?
Yeah, it's completely anonymized. I said it very quickly, but before sending the data, we don't even have a key. I can even tell you that for Cisco IT, I don't have a key. I can't see for the same reasons, which is privacy. So we encrypt everything with a key that we don't have. This is owned by the customer. And then we run the machine learning algorithm in the cloud on, as a SaaS application, then it comes back. So we raise the anomaly, but we have no idea. And then it is being decrypted locally by the customer.